Hi everyone. In this video, I just want to introduce a couple more basic differentiation rules. One of them is when you have sum or the difference of functions. So when you have more than one term of functions, how do you differentiate that? And then the second one is when you have some constant is multiplying some function. How do you deal with that constant? So let me just write down the rules first, and we'll go through some examples. Okay, so this first sum and difference rule basically says that if you are trying to differentiate the sum or the difference of two functions, then you can basically differentiate term by term, right? So if you have f of x plus g of x, the derivative is going to be f prime of x plus g prime of x. And if you have f minus g, then the derivative of that function is going to be f prime minus g prime. And in the second rule, if you happen to have a function, say f of x, is being multiplied by any constant c, notice that in this case, this rule basically tells you that you can pull out that constant c that you have outside of the differentiation. So it is going to be the same thing as this constant times the derivative of the original function f of x, and the result is going to be that constant, same constant, times the derivative of f, which is f prime. Now, as the third one, I could actually list this as the third rule. If you are differentiating any constant c, so c can be any constant. Now, if you think about the fact that we had this example in the group activity, is that if you happen to have y equal to c, if this is the function, this is going to give us a horizontal line, isn't it, where the y value happens to be c. So the graph is going to be something like this, where that y value is going to be c. Now, any graph like that, if you think about the tangent line to this graph, it is going to coincide with the horizontal line, which has the slope 0. So any of these constant function, the derivative should be exactly 0. So this is also something that you might want to remember. So now, using these basic rules, let's try to differentiate the following. I'm going to give you two examples. So let's try. So the first example, let's do f of x equals, say, x cubed minus 2 square root of x. So first off, I do have a difference of two functions. So using rule number 1, let me just indicate which rule that I'm using here. Rule number 1, I can differentiate term by term. So that would mean that I can differentiate x cubed minus the derivative d dx of the function 2 square root of x. But let me just write that square root of x as x to the 1/2. So this is using rule number 1 there. And using rule number 2 at this point, note that I have this constant 2 is multiplying that square root function. So rule number 2 says I can bring that outside of that differentiation. So this is going to be d dx of x cubed minus 2 times, because 2 comes out, d dx of x to the 1/2. So all I need to do is to differentiate each function using that power rule that we talked about. So the first one, x to the 3rd, 3 comes out, and the new exponent is going to be 3 minus 1, which is 2, minus 2 times, so let's see, x to the 1/2, so that 1/2 comes out, and x to the 1/2 minus 1 gives me negative 1/2. So by simplifying the result, I get, now 2 times 1/2 is just 1, so that's going to be x to the negative 1/2. Now if you feel like you need to rewrite that negative 1/2 exponent as 1 over square root of x, that's fine, but I'm not going to worry too much about that step. For the second example, let's try this function. Now when you look at this function, you might be thinking that, well, we haven't done any rules that we can apply to differentiate this, but if you look at it, you realize that this can be simplified by separating the fraction into 4 different fractions. So this is what you should get. So just like when you have fractions with the common denominator, you can combine them into 1. I can separate the original fraction into 4, as you see here. So each fraction, we can now at this point use the properties of exponent to simplify each of them. So let me just rewrite each fraction as follows. Now remember that you need to do top exponent minus the bottom exponent, right, when you have division. So in this case, x squared, so that's going to be 2 minus x to the first. So 2 minus 1 gives you x to the first plus. Now this one you might be thinking, I don't know what to do with that, but it's still the same properties of exponent. So it's going to be 2 times x to the, so what would be the new exponent on this? In the numerator you have x to the 3/2, then divide that by x to the first, so 3/2 minus 1, that is going to give us 1/2 minus, now that one is going to be x to the 1/2, divide that by x to the first, so 1/2 minus 1 is going to give us x to the negative 1/2, and minus, now in this case x cancels out, right, so 1 minus 1 is 0, so that's going to be 3. Okay, so now that I have sum and the difference of x to the power, I can definitely differentiate term by term. So f prime of x then is going to be, so let's go through this one a little bit faster. Derivative of 4x, that's going to be 4 times derivative of x is going to be x to the 0, which is 1, so it's going to be just 4. This, again leaving the 2 outside, 1/2 is going to come up front as the coefficient, so let me just write it that way. 2 times 1/2 x to the negative 1/2, because 1/2 minus 1 gives me negative 1/2. Now the next one minus, right, because that's the difference, and this negative 1/2 would come up front, so that would be negative 1/2 times x to the negative 1/2 minus 1 is going to give me negative 3/2. Now remember the last one, negative 3. Derivative of any constant is going to be 0, so that is going to give us just 0 at the end, but of course you don't have to write that. So simplifying the result a little bit, this is what we should get. We have 4. 2 times 1/2 is going to be just 1, so that's going to be x to the negative 1/2. And negative times negative 1/2 is going to give us plus 1/2 x to the negative 3/2. So as you can see that using the power rule and also the sum and the difference and the constant times function, as well as derivative of this constant being 0, we get to now differentiate quite a bit of functions that are out there. So make sure that these rules, you know what they are, and be able to differentiate these functions that you see in these examples.